So this is the last class for the Python for linguists. And yeah, Jacob will be taking us through the last class. I hope you enjoy it. Thank you.
All right, so we're gonna get started here. So, hi everyone. Um, Thank you for joining me this far, I suppose. Um, so my goal for today is to give you the final skills that will let you not just be able to uh, understand how to write your own code, but also there are a few more things that are really useful if you want to try using an external library. And so today we're going to start by talking more about ways you can store data. And then we're going to transition to what it looks like to actually try to read an external library and install one and use it and see how it works. So, um, I know in one of the previous classes, someone was asking like how to use a pandas data frame. Um, that we're not going to talk about pandas directly. Um, I thought about doing that, but it would introduce a bunch of complexity that wouldn't get you to the core concept of what it's even trying to accomplish as efficiently as if we did this a slightly different way. So with that said, let me start sharing my screen. And actually, I should do this. Well, no, I shouldn't. Okay. Screen should be visible now. So the first thing I want to start with is I want to revisit lists. They're kind of at the core of a lot of the stuff that makes more advanced programming work. So we've talked about lists that look, kind of in their simple form, right? So let's just make an example. Let's just make it a list of numbers. I don't know, 23, 56, 89. That's some numbers. Um, so talked about, the fact that you can, I don't know, for example, print out just one of these numbers. This would be the middle one, right? This would be at index 1 is the second number. It's a list of 3. So it'd be this one. Let's run this and just confirm that. So let's open this up. Whoops. And here it is, 50. Whoops. Let me make this visible. Here it is, 56, just as expected. So the first thing I want to talk about today is um, when you're making a list can be of any kind of data. In this case, it was a list of numbers. You've seen lists of strings, but another thing you can make a list of is you can make a list of lists. Say this one is just 21, 23. This is also a list. It's a list that contains 3 lists within it. And that is a perfectly valid thing to do. If I print out the second item of this list, as I've done here, the second item of this list is this list. I could additionally print out, I don't know, the third item of that list. This is how I would do that. This, if you prefer, it works just as well if you put this in parentheses, right? It's because this is a list. In fact, it's this list. You can get an item from this list. Let me get rid of the parentheses. And it will work just fine. 90 is indeed the third item of this list. So in this case, I'm hoping this is at least a little bit straightforward because, everything's right in front of you. There not a bunch of variables going on or anything. You could do this here. You can think of this as like a two-dimensional list. You could do this with as many dimensions as you want. If I wanted to, I could throw right here yet another list. And now at this point, there's a third dimension. And if I print this out, I've placed it at the place this describes. So you will see that this itself is a list. And so I could go even further. At some point, it's not necessarily so useful to have like a 7-dimensional list very often, but it's good to know that the concept keeps working. Uh, there's nothing special about a one-dimensional list, just a list of values. There's nothing special about a two-dimensional list, a list of lists. And there's nothing special about a three-dimensional list, which is a list of lists of lists. It all works on the same concept. You can access individual parts of it and treat them like you would any list. So this way of thinking about things can be pretty useful. It can really help us get things done that we want to get done. So for a really kind of basic example, it's pretty common as linguists that, we have a large amount of text that we want to deal with, right? And it could have quite sophisticated structure. In fact, when we're dealing with syntax, um, you could encode an entire syntactic tree with each layer being its own list of elements. So if I were to, let's right after this, well, I'll get rid of this print statement. Let's say I wanted like a basic syntactic analysis of a sentence like, I don't know, uh, the child found a ball. Then, very briefly, right, we'd have something like, and I'm gonna, theories of syntax vary. I'm gonna just go for a very simple analysis of this that, will work for our purposes of explaining the concept I'm trying to explain. If you believe that this should be analyzed differently, that's totally fine. The programming part is the part I'm trying to get to here. Uh, as long as it has a nested structure, we'll be able to be on the same page. So a bracketed representation of this might look like, well, this whole thing is a sentence, um, and it starts with a DP, which itself has a D, which is the, and an NP, which is child. And then it has a VP, which itself has a V, which is found, and then a DP, which is a D, NP ball. I don't really agree with the syntactic analysis. And for those of you who are less familiar with syntax, all I'm doing here is just grouping up different parts of this. I'm saying that, this whole thing is a sentence. It has a determiner phrase, the child. It has a verb phrase, found a ball. Inside of found a ball is a determiner phrase, a ball, right? So ignoring the labels here for a moment about sentences and DPs and NPs, I could very easily make a list of lists, etc., that represents this internal structure. So let's take my sentence here. So I'm going to say the whole thing, right? This is going to be the whole sentence. There's going to be a list in here of the elements of that first DP, which is going to have a list for just the first D, the, and then here's the NP, child. And this is that first DP. To help myself here, instead of retyping all of this and trying to get the brackets right without all the labels and stuff, I'm just going to do this. I'm going to get rid of these labels. And wherever I see a word, I'm just going to put quotation marks around it. And there we go. This will be a little bit easier to read. I spaced it out like this, which should work fine. And the spaces here don't matter. I think this is the nicest spacing of it, but that doesn't matter at all. This is a pretty complicated piece of data in terms of the structure I've given it. There are many layers of lists here. So with that said, what I've accomplished allows me to do something like this. So first, let's just see what it looks like to print my sentence. Oops. I forgot the commas. That is on me. So I need a comma here. And I need, because the only way these work is as lists of elements here in the same way that these work. So let me make sure I've gotten all the commas I need. That should be right. Yeah, there we go. So here's the whole sentence, right? The child found a ball. Now, I could split this up and just print out that first DP. It's the child. I could print out, let's say I want something from the VP, and I want something from the direct object of the verb. That's going to be the second thing in this VP. And specifically, I want to know what determiner it had. It was uh. So again, right now I'm just using the specific thing that I had in this sentence, but now let's get fancier. I want to make something fancier. Oh, I want to make a bit of an echo somewhere. Looks like it's
Yeah,
gone away.
I'm trying to fix that. Fatima or something. Okay, they've muted themselves. Thank you. Sorry.
Okay, where was I? Right. So when dealing with lists and complicated structures of lists containing lists and so on, um, it can be really nice to think about how the data is structured in general to be able to view it in better ways. So for this, a really nice way to view it would be to be able to print this whole thing out in something that kind of has a bit of a tree structure. So here's how we're going to do it. I'm going to make a function that can print out things in a list where it checks if there's a list inside of that list. And if there is, then it will print that part out with, a further indentation. And this operation is a little bit complicated. So let me try actually writing it out. So this is going to be like a print tree function, right? This is for a syntax tree. So I'm going to give it a tree. It's going to print it out. So the first thing I'm going to do is I'm going to check, is the tree that I'm looking at, is it just a list of stuff and not a list of lists? So the way I can do that is first I want to check if there's anything in here. So if the tree is an empty list, then I don't need to do anything. If I want to just end a function, I can always do a return that doesn't return anything. And that's completely fine. Okay. So if I make it past this point, then I know that the tree has something in it. Okay. Now I can check, are we at a level that contains more lists? Or, well, actually, let me do it like this. For each element in the tree is how I really want to think about it, right? So for each item in the tree that's at the level I'm currently looking at, if it's a list, I want to do something different than if it's just a string. So I can check if the type of I is the type of a string, then I know, I can just print out that string. And specifically, I'm going to want to not print things out by making a new line at the end. The way to do that is by default, this is just the way printing works. By default, printing out will make a new line after each print statement. Doing this will stop it from doing that. It says when you're printing out, don't end with a new line, instead end with nothing. So if I'm looking at a string, then just print it out. Otherwise, well, what do I want to do here? I want to print out what's in there, but that I want to do on a new line, and I want to do it indented. So what I really want here is something like this. And this is where things are going to get a little bit fancy here. I want to, at each point in the tree, is something that is itself a tree. I want to do something like that. And now that I have it like this, I actually don't even need this because now I've made a for loop. And right before this, I'm going to want to print a new line. All right. Now this code is pretty funny looking. Let's try actually running it. So I'm going to print tree with my sentence, and I'm going to start like that. That didn't quite work. That's because I forgot to do this. That was the whole point of doing that. There we go. So what this is doing is, depending on how nested something is into this structure, it's putting it farther out like this. This is a little bit too much space for me. I think that's a little bit nicer. So I should probably also instead of doing this many, this has a bunch of new lines that I don't need because there aren't strings on a lot of the layers here. So instead of printing a new line here, I probably want to print a new line only when I'm going to actually print one of these out. So for now, actually, I probably don't even need this. What this is reporting is that all of these are indented in somewhat. They're at the same level of the structure, and these are further in. But if I now made my analysis where these are further in than this, like for example, by doing this, which would correspond to doing this, and let's do this 2 spaces again. I will see that reflected as this. And I can start seeing the actual structure of this tree. At the top level is this DP and this VP. Within this DP is just this noun. Within this VP is a DP, which contains this noun. And if I were to make this more complicated, perhaps, let's say I want to make it the child's friend or something like that. Then I could just say that that's the child something like this, which would correspond to adding another layer of structure around the child here. That is another DP. So that would be the end of that. And then there'd be another thing here, which is apostrophe S. And then another 2 layers of structure for friend. Oops. If I've done this correctly, I have not. Whoops, I forgot to add the closing for that. And I forgot to do this, as usual. Okay. Nope, missed another one. Right here. Now this is indented inside of this, and friend is at the same level as the. The way this works, by the way, and the way trees work in general, is through something that computer scientists and sometimes linguists call recursion, right? And you can tell that this is recursive because I'm defining this function print tree and using it in its own definition. This is some really fancy programming, but it's at the core, this kind of idea, thinking about lists as structured in this way, is at the core of a lot of stuff that you see in scripts that people write for doing linguistic analysis. It's not the most simple way to think about it, but especially if you really understand how a syntax tree works, the same kind of embedded structure can happen inside of Python. And in fact, by the way Python itself works, um, programming languages themselves work in big syntax trees, but that's a topic for another time. So, um, one nice thing to do here, you can, when you're making a function, you can give one of the parameters a default value by doing something like this. And this will make it so that I don't have to add that. This is saying by default, this parameter is going to be nothing. So if I just do this, then it will default to this value. But when I call it like this, where I supply that value, it will be whatever I supply it with. And this should do the exact same thing. But let's make this even a little bit fancier. But I'm going to come back to that in a second because I want to talk about dictionaries. So a common thing to want when you're dealing with a bunch of data in general is to not just have lists of data, but to have lists of data that correspond to something in particular. So by default, the structure of a list gives you a correspondence in the form of, you get a particular index that's a number for where you are in that list. But sometimes you want things to correspond in a different way. So, for example, I might have, let's say, a list of people and a list of each of those people's primarily spoken languages. So I might have, people and their names. So I don't know, let's say Harvey, Jose, um, let's say Lee, and their languages
Gloria.
are English, Spanish, and let's say Mandarin specifically. Where I mean to have this represented where Harvey corresponds to English, Jose corresponds to Spanish, Lee corresponds to Mandarin, right? So I could have this in two separate lists. And then, whenever I need to do something with each one of these, then like I have them matched by index, right? So if I want to know, let's say I make a program um, that you can enter a person and it says what language they speak. Lets them input a choice. And then I want to say, if they enter Lee, it should print out Mandarin. Well, the way I could do that is I'd have to look through the people list and find the index where Lee is so that I can get the index of this list, right? So it'd be something like, if it's their choice, whoops, I need it to be like this. And by doing that, this would work. So I could do Python. So I could enter Lee and it would say Mandarin. I could enter Harvey and it would say English, and so on. But there's actually a Python structure that does all of this much more simply, and that's called a dictionary. Instead, I could make a list that looks like, I could make a dictionary that looks like this. Let's call this option 2. So I could say, with these curly braces, I have an entry for Harvey, and he speaks English. I have an entry for Jose, and he speaks Spanish. And I have an entry for Lee speaking Mandarin. Now, instead of doing all of this, it's as simple as printing out I can just say what the choice was, and these are indexed by the name. This will work the exact same way. This is called a dictionary. And it is specifically the tool made for this purpose. And it's a really, really nice tool. Now, instead of having to maintain 2 separate lists, I have just one list that has the correspondences all here. Harvey goes with English, Jose goes with Spanish, Lee goes with Mandarin, and give me a person, and I can give you their language. So to be clear, if I wanted to not make this a user choice, but just do something like this, this would work just fine. If I say specifically Lee, it will give me specifically Mandarin. These are really, really, really nice for dealing with a bunch of data. So here's a common thing that you might want. You might want to take, let's say, yeah, sure. Let's do the similar thing with what we've been doing, where you have some kind of, let's say you have a sentence and you want to count how many of each letter is in it. That's a classic dictionary task. So let's get rid of this. Let's use that same sentence from before. I liked that sentence. What is it? The child's friend found a ball. Great. So if I wanted to count how many of, like, for every letter in here, I want to count how many of that letter is in this sentence. If I want to do that with lists, then first I have to go through and find what all the different letters are, and then I need to make lists for all of them, and it'd be a whole thing. But doing this with dictionaries is very easy. So I'm going to start by just making an empty dictionary. So let's say, let's call it results. And to make it empty, doing this is actually an empty set, not an empty dictionary, and that's a whole other thing. The easiest way is just to do this. And that makes an empty dictionary. So for each character in my sentence, all I have to do is see if that character is already in my dictionary. Whoops, not in my sentence, but in my results dictionary. Then, well, actually, let's start with if it's not. It's not in my dictionary. Let's do it like this. Then all I need to do is say results at that character equals 1. And if it is in my dictionary, then results at that character plus equals 1. I can just print out the results. And I will see something that looks like this. So there was 1 T, there were 2 H's, there were 2 E's, there were 5 spaces. I'm looking at every character here. There was a C, there was an I, there was an L. Sorry, there were 2 I's, there were 3 L's, and so on. Which, just to check, like here's the L's, right? 1, 2, 3. Here are the I's, 1, 2. There was, in fact, only 1 T. This is just giving me all of that information at once. Really convenient. If I wanted to, perhaps just look at the most common ones, then after getting these results, I could do something like, and here's something fancier, right? I could do something like for each letter and its count in my results. Let's just say I want to look at just the ones where the count is greater than 2. Print letter. Let's just do it like this. Right. Sorry. Uh, this is a problem that I get when I program in multiple languages. You can't actually do this with Python dictionaries. You have to do you could do it like that, but let's just do it like this. There were 5 spaces, 3 L's, and 3 D's. Really convenient. Okay. Here, what I really want to represent the syntax tree is I don't really want I want this structure to not just be a bunch of lists of stuff, but I want them to be named. At the top level, this is a sentence. Then, at this level, it's a DP. I want that name to be to correspond to it, right? Um, so really what I want is a list of, getting a hand raised.
Can you hear me? So
Yes.
yeah, there is a question. I don't know whether you answered it. Can we zip the list as well?
Ah, um, someone knows about zip. So one thing I haven't talked about is how tuples work. Um, oh, actually, let me just the question a second ago there is very
Yeah,
quick
they
to
say
answer. Can pass
can
take the
pass
place of
take the
return
place.
in my
Yes.
function? Pass specifically does nothing. So doing nothing is not the same as exiting a function. So pass and return do very different things. But now to answer the question about zipping the lists. So that is a different way that you can make these kinds of structures. And that will make you, what zipping the lists means is making a list of tuples, which is a different kind of structure. Um, I find, so there's only so many things I can talk about in one day here. Um, in my opinion, you're much better off knowing about lists and dictionaries than knowing about um, lists and tuples. And so I figured we're not quite going to have time for talking about that. And zip is a fundamentally tuple-based idea. Um,
Mhm.
if you happen to know about zip and you know about tuples, then yes, absolutely you could do that. And that's a different way you could get at the same task here. And in fact, if you know about tuples, then you can also break down a dictionary into its corresponding tuples and interact with it that way. But that's a topic that, for time reasons, I'm not going to get into today.
Okay, thank you. One last question. So if you look at for, can you walk us through the last function, like the character, the first if statement, it's saying, I mean, the in the first for loop,
Oh, this one?
the yeah, the if statement there, it's printing out the character the first time. So why do you have one there? Do you want to count it? But I thought you wanted to increase the number.
Ah, so I'm saying if that character is not already in the dictionary,
Mm-hmm.
if this is the first time I'm seeing it, then the count is one.
Okay, then it begins to increase the number after you've seen it.
If I've seen it before, then I want the count to be however many I've seen before plus one. So let's act like a Python interpreter here, and let's try actually kind of running this code in our heads for a second.
Good.
Um, oh, one thing I didn't actually say specifically, if you want to add something to a dictionary, um, I do in my example dictionary up here, it's as simple as you can just access it as though it exists already and say what you want the value to be. So um, I can add, oh, I don't know, let's say I'll add myself. Uh, and just for, some more excitement, I'll say that I study a lot of Latin. Whoops, not like this. Now that I've done this, if I were to print out the whole dictionary, then that entry, whoops, that's not the window I wanted. That's the window I wanted. Here's the whole dictionary, right? It's got English, and it's got me at the end with Latin. Adding something in is as simple as that. And afterwards, I could access it in, the same way I could access anything else. So here I'm doing exactly that. So when to go through this code in order, right? This is going to go through each thing in the sentence in order. So when I see the T, um, I'm starting with an empty dictionary. So T is definitely not going to be in it. So I'm going to make a dictionary that is so far just a T and it's one. In fact, actually, let's make this much shorter. Let's say this sentence is I like, I don't know. Um, let's say it's I like you. That's a fine sentence. And at each point in this for loop, I'm now going to print out what results is so far. I'll even do it like this. So you can see how this really works. So it starts by getting that capital I. Let's make it all caps. Because remember, there's a difference between capital and lowercase. Okay. So it starts by getting that capital I. Then it gets the space. and it gets the capital L. Then it sees, right? So it's gotten the I, the space, and it's made entries for them. It gets the L, and then it sees this I, and that's when it goes, okay, I've seen I before. C is in the results. So I'm just going to increase that by 1. And you go from this to this. And then it gets the K, then it gets the E, and then it gets another space. And it gets the Y, the O, and the U. And in fact, that's the final result. None of the letters were there more than twice. Um, let's do he likes her. And then you'll see down there at the bottom, E shows up 3 times here. But this is going in order, right? First, it's finding that H, hasn't seen that before. So it's going to make an entry for H and set it equal to 1. Then it's going to get the E, hasn't seen that before. So it's going to make an entry for it, set it equal to 1. Then it's seeing the space, make an entry for it, set it equal to 1. Then it's seeing the L, the I, the K. And the first interesting one is at this point, it gets to this E, which it has seen before, increase that by 1. That's all this code is doing. It's just doing it quite efficiently, I would say. You could make this code with just lists. It would take you a little while. Okay. Any other questions?
So yeah, there are two questions here. Somebody's asking why not just for C in my sentence results, you get the index of the result, then you increase
So
it
why
by
can't they
one.
just do this?
Yeah.
Let's try it. That's a great question. What it will say is key error, which is the same as it would say if up here I tried to print out example dictionary and, let's do something that's definitely not in there. Then I would get a much earlier key error. There's no data in here for this, so I can't print it out. I could put something in here at that spot, but there's nothing already at that spot. Same problem here. If I just did this, there's nothing already at result C, so it can't add 1 to it. Remember, this is a shorthand for... And this, it can't evaluate this. There is nothing at that spot, right? There is no results C to add 1 to. That's why I need to check first if it's not there, then I need to make an entry for it.
Yeah.
Once it is there and it's equal to 1, then I can add 1 to something that exists. Okay, looks like there's some more. All
Yeah,
right.
there's how can I go about a different list and we want to mark both lists as per their index?
So are you saying if I already have the lists, how do I map them together into a dictionary?
Yes, I think so.
That is specifically
What?
what zip does, actually. So I guess I can do it like this. So let's say I'm going to do this in a separate files. Otherwise, well, I don't need this in a separate file. Um, let's remake our example dictionary a different way. So actually, I'm just going to make another one here very quickly. So let's say I have list one, and it's equal to, and I have a list two, and it's equal to 34, 65, and 78. And I want to make a dictionary that puts those two together. Um, and this is just an arbitrary variable name. Remember that, always works like that. I can literally just do, whoops, dict zip L1, L2. Explaining how this actually works is probably a little bit above the level of where we're at, but it will work. If I print out my dictionary after this, here it is. I'm also still printing out everything else, but here's that. And that's how you would do that. Okay. That's an interesting question. Someone's asking me why in some of my for loops I just have a single character for the variable that's iterating over things, and for some of them I write a whole word like letter. And the answer is um, I do that entirely based on how obvious it is to me what I'm iterating over and how much I want to type out a longer word. It's entirely a style thing. You could have a completely different style. You may not like my style. That's totally fine. Um, there is no difference in terms of functionality. It's just completely my choice of names. They will do the same thing. If you remember the example from a couple of classes ago where I gave everything ridiculous variable names. These are just variable names. I could name them whatever. For me, C is a nice thing when I'm going over these characters, but for some reason I thought it made more sense to do letter here, and it's completely arbitrary. So no special meaning. And I think that's all the questions that we have right this second.
Yep.
These are
Thank
great
you.
questions, by the way. Okay. So now that we're on the same page about all of that, what I really want here is I want to know that um, this thing, the child, is a determiner phrase, and that, this thing is a verb phrase, and that the whole thing is a sentence, and so on and so on. What I really want is a nested structure not of lists, but of dictionaries, so that I can get, you know, the determiner phrase out of the sentence, and I can get the verb phrase out of the sentence, and so on. So I'm gonna remake this. I'm not gonna destroy this, but I'm gonna remake this as a dictionary. So let's say, so I'm gonna make this whole thing. Oops. This whole thing is a dictionary that is just one entry. It's a sentence with all this stuff in it. This part should also be a dictionary. This is the DP, and it ends here. And this is the VP, and it ends here. This right here is also a DP. And there's no problem with having something with the same name inside of something else. Not a problem at all. So this DP itself contains a D, which is the, and an NP, which itself contains an N. Oops. Which is the word child. Okay. I'm going to make this a little bigger for myself so I can see it better. Okay. Make sure I'm up to date here. Yep. So I haven't closed this DP yet. This DP is the child. So it should end. Oh, that's the end of the NP. And there's the end of the DP. There we go.
I think you are missing your the. Can you see the? Can you see child? Yeah.
When you're working with data like this, you have to do it carefully. I expect, by the way, I was expecting to make some mistakes. If I do this with making no mistakes, that'd really be quite something. All right, I'm going to put this at the same level. There should be a comma here. And then let's put this on the next line. This is an NP. And again, the point of this is not the specific syntactic analysis. You could do exactly what I'm doing here with whatever actual structure that you think should be here. Okay, that's the end of the N. That's the end of that NP. And yeah, that's the whole DP. Great. Okay, now I have the VP. The VP has this verb. I'm going to move this whole thing down after print tree. Okay. Where was I? Has the verb, and it has this DP. Which should end here. And it has, whoops. There should be a comma here. This D is and then it should have the NP. And I promise there's a reward for putting in all this work. Okay. Nope. Okay, there's that. And that's the whole DP, that's the whole VP, and that's the whole sentence. Okay, great. I've now made a dictionary out of this sentence. So what can I do with this? Well, first, let's make sure I did it right and just print it out. Um, so I'm no longer gonna, well, no, I'll leave the print tree there actually. Yeah. Let's clear the screen here. I got a lot of course messed up right here. Python doesn't like that. Um, believe the character to wrap on the next line is that one. Yeah. So just what I'm doing here, by doing this, it allowed me to write this on the next line just to make it easier to see. I could have accomplished the same thing just by doing that, but I don't like the way that looks, so I did it like this. Nothing special going on there. Okay, now it's saying um, I messed up my brackets at specifically here. It's a very nice error, by the way, that it tells me right where the problem is. So let's check it over. So that's my sentence. That seems right. Um, that's the start of that. Okay. Yep. Yep. Okay. Wait, it's at the level of NP and child. That should be fine. What did I do wrong here? That's a dictionary containing this DP. Oh, that's the problem. This DP contains this D, the, and this should be at that level. Yeah. This DP is this dictionary. Wait, did I do that right? This DP has as its value this dictionary, and then it should go straight to the NP, which has its value. No, that's not right. Oh, I think I just had a, let me try that. Nope, I still have a problem here. Hmm. So this is the problem with trying to write out a whole dictionary all at once like this. You get into some really, really annoying situations like this where it's actually very difficult to see how this works specifically. So, um,
I'm actually wondering whether there is a way to convert that automatically. Can you write a code for that
of
and
course,
see if that would work?
I absolutely could. And in fact,
So I'm
I
wondering
already
if,
have the right code to do it
yeah,
right here.
yeah.
So rather than try to build this like that, this is not working at all. Instead of printing things out here, what I'm going to do is stop trying to do it like this, and instead, um, I'm going to just go through this list and build the dictionary that way. So I'm going to start by making the sentence. And for now, I'm going to say that this sentence is going to hold. I see. I'm doing this backwards. Rather than do this from the top down, I'm going to do this from the bottom up. So I'm going to build, let's start with, I'm going to build each individual one of these things that actually have the actual word. So D1 is a dictionary that goes D, the, then D2 is D, let's see here. N1 is N child. N2 is, and I'm already tired of doing this like this. This is really annoying, writing out every single thing like this. So instead, I'm just going to make something that I'm going to make myself a little function that can make these dictionaries. So it's going to take in the name and the value. And it's going to return but the whole point of this is do it faster. And sometimes I'm going to have the same name over and over and over again. So I can do it like this. I'm going to get all of the determiners. Now, doing this way, I've gotten all the determiners at once. I can just do this again, but with n word for all the nouns. But this still is kind of annoying because I can just have a list. I want to just be able to do all at once D and then get all of these. So I'm going to do this. Name values for word in values. And the reason why I'm going through all of this, by the way, is it's really important to be able to think of things this way. Like, that's why this lesson, like, it's a lot more of me trying to write code to show you something. I'm trying to get a really big concept in kind of all at once. Okay, so that said, where was I? Right. Now I can just do D, and now I have the done. That's much better. So that's all the D's. Now for the N's, I can do child friend ball. And then, oh, I missed a D. I missed this one. The apostrophe S. That's the, but I'll keep it in order. All right. And then there's just the V for the verb. Nice. So now that I have all the things at the bottom, I don't think I'm missing anything. I can use this same approach to build the next thing up, which is let's build up all the NPs. Well, the NPs is just making a dictionary out of NP, and then that's it. Now I have an NP for each of these. Now to build up all of the DPs, I just need the now I'm going to have ones that are a little bit more complicated. So I'm going to make this manually. So the DPs are going to be get this right. The first one's the most complicated, so let's just do this one first. It's the one with and ball. So it's going to be a dictionary. So let's just do the last DP is going to be a dictionary. It's going to be DP. And its value is going to be the last NP I made with the last D I made. So it's going to be a dictionary. Sorry, it's going to be a list of two different dictionaries. It's going to be the last one of these, and it's going to be the last one of NPs. That's the two things that are in this DP. So specifically, I made a list of them. And I think that's what I messed up before. I meant to do that, but I wasn't making the lists correctly. Okay. Then so that's the last DP. It belongs inside the VP, which is going to be VP. That's going to be, actually, this is silly. I don't need to make a dictionary for this. I can just do the VP is going to be a list of the V and the last DP. And I'm done with that side of it. Now to make this part, The whole thing is going to be a DP, but I need to make this internal one first. So let's call that the first DP. And that's going to be it's going to be D's 0 with NP's, right? It's the child. Then the whole thing, the big DP, right? I'm not missing anything. No, I'm not. Is going to be DP with the first DP, the second of the D's, and the second NP. And then I can make okay. Last DP. Nope, that's not the order I want. It should go big DP, then VP. And that should be it. Let's just see what happens if I print out that sentence dictionary. Huh, that's a big problem. Let's try that again. Oh, this shouldn't be return name word. This should be I meant to add it to the list and return the list. There we go. And here's the whole thing. So what does this let us do after all of that work? There's one more thing I want to show you, which is you can run a program in interactive mode to be able to
Can
interact
you
with the
wait a
whole
bit,
program.
please? Who is this
So
guy?
now
Who
I'm
is
going to
this?
do Python I more list.py. And now it's giving me this thing. So I have my sentence dict. So just to show you, I'm now in an interactive mode of Python. So if I do something like, right, it's running this as Python code. And I'm in an interactive mode that just ran more list.py. So now I can do sentence dict VP. Whoops, is that not what I called it? Oh, of course. The top level is just S. And then I can do and that's the VP. Whoops. I've made a mistake here. I have this extra layer of structure I don't want. What I really wanted was not to make lists of these, but to make dictionaries of these. But I hope the idea comes across anyway. I'm running out of time here to fix my mistake. That's the problem with programming live. Uh, this is something that I should have practiced a little bit more before coming here. Once I get into the more complicated stuff, to do it right the first time is a little bit trickier. But I wanted here was, of course, these should be nested dictionaries. So this should work differently. Um, this shouldn't make a list. It should make a dictionary with a top level name and a bottom level name. But I'm running out of time to fix that. So for now, this will do. I can do something like 0 and then I should be able to do that. Hold on. Oh, yeah, there we go. And there's a ball. So this is a gigantic structure. It's very complicated, but it has everything labeled. And so if I had code that built something like this, which there are libraries that do that, then I can move through it like this and use both the labels of the kinds of things and the things themselves to do various kinds of analysis. So for example, I could use this to determine if I had a bunch of sentences that were tagged like this, I could use it to determine how many sentences have direct objects in their VP. This one does have a direct object, right? The child's friend found a ball has the ball, but maybe, other sentences would just be like the child's friend jumped, right? That one wouldn't have a direct object. And I could find that out by recursing through this structure and seeing if it ever has a VP in it, which I could do very similarly to the code that I made here by looking at all of the branches and seeing if there's a VP in, various parts of the structure. Okay. So this kind of stuff, when you really want to get into storing a bunch of data like this, and giving it complicated labels and arrangements, there's all sorts of things that can happen. And there are libraries that are built specifically to make this kind of thing easier. So, like I said, we're not going to have time to actually get into pandas, but all of the stuff I just talked about with the way that things get structured and the way dictionaries can be nested inside of lists, that's how pandas actually works. If you want to know how a pandas data frame works, it works like this. And with that said, I want to show you what it looks like. I'm going to go with a much simpler library, the requests library. But I want to show you what it looks like to actually look at a piece of library documentation. So first of all, this is just like what these typically look like. This is I just Googled requests library because I know that that's a library that exists. So just very quickly, let's exit this. If I want to install a library, it says to do it like this. Okay. I don't actually have to do Python M because of the installation I have here. I can just do pip install requests. And there we go. Now I have it. Cool. Now, this is a complicated example, but if I want to use requests, I should be able to. If you're using an external library like that, you have to install it. So a lot of the pages for these kinds of things, they look like this. The point of this lesson is not to specifically learn the request library, but to learn how to read a library. So you'll often see examples that look like this. Whoops. Um, you'll see, like a description of the features. What this is for is it allows you to, in Python, interact with web pages. It's useful for scraping data off of web pages, something that linguists want to do sometimes. I've been in situations where I need to research something, and the correct thing to do is just to scrape Wikipedia to try to find it. This is how you would request things from Wikipedia this way if you wanted to do it kind of that basic way. So, okay, I've installed requests. Let's look at the quick start. Make a request. Import requests and do this. And it tells you, like try writing this code. And it tells you what it does, right? You can pass parameters into URLs and it gives all of this stuff. So here's an example code that does this. I'm going to do this with a much simpler web page. Here, I'll show you the web page I'm going to do this with. This is crouton.net. It is just a picture of a crouton. It's my favorite website. So just very quickly, let's try to do import requests. And let's check this quick start for how to do this. Okay, I don't need anything that complicated. Let's try just doing requests.get. Okay. Import requests. And what did it say to do? R equals requests.get. Okay. I don't need that open. R equals requests.get. And then I believe the next thing is just the URL. Yep. So let's do this. And then print r.text. And look at that. This is the code for the web page of crouton.net. You can see it's just the title is crouton. It has the image and stuff. Um, you could there's a whole thing you could get into about like how to use this information to actually find the things you want. The way web pages work is they have all this metadata that says how it's structured and stuff. We don't need to get into that right now, but this is successfully using just straight out of the quick start. I tried doing this and saw what it did. Fantastic. I can look at the encoding, apparently. I can look at the content this way. So clearly, there's all sorts of stuff I can do here. So once I've gotten what I want out of the quick start, that might be all you need, right? All you need is just look at the quick start. You want to do exactly what it says to do. That's great. But now a different thing that these always have, something like API reference. And for that, you'll get big pages like this. Some of the libraries you might want to use don't even have a quick start. So one of the libraries I wanted to use before is called Parselmouth, which is this is for using the program prot, if you're familiar with it, for phonetic analysis in Python. It's a great library, but it has a couple examples that it links you out to. But other than that, if you want to know how it works, all it's got is this huge list of functions, and that's all it's given you. If you want to know what convert to mono does, then you have to just figure that out. You can look at what a parcel math sound is, and this is one of the harder libraries, I think, to understand how to use. And when I've tried to use this, I need to do a lot of Googling to see what any of this is. Like, I don't know by myself exactly what the parcel math sound file format is. Apparently, this is it. It has this stuff. I don't know what next sun means. Working with libraries like this can be a little bit complicated. The nicer ones give you whole descriptions. So we used, what was it, request.get. So let's find get in here. Ah, here it is. Request.get sends a get request. Fantastic. You can give it a URL, right? Here are the parameters. You give it a URL. Optionally, you can give it a query sting for the request. I don't even fully know what that means. Okay. And apparently there are optional arguments that request takes. So what does that mean? Well, it must mean the optional arguments that this can request. And in fact, here they are. If I wanted to give it some cookies, I could give it some cookies, apparently. But it says it gives me a request response. So now let's look at what a response has. I can close it. I can look at its encoding. I can iterate through the lines of the request. I can look for any links it has. I can look at its raw representation. Apparently I can do all sorts of things here. This is what documentation looks like. So I might need to look at the documentation if I'm getting some kind of error, right? This is where if I'm getting some kind of error or I need to know how exactly am I supposed to call this function, then this is the best way. You'll have these giant lists of exactly what the parameters of every function are. This is why understanding functions is so important, by the way, so that you can really read something like this and understand what it's saying. It has parameters and a return type, right? This is where all that comes into use. So if you look at the pandas documentation, right, here it is. This is a very useful one. It has something like getting started, right? It has installation. You can do pip install pandas. It pandas has this really, like it has all this stuff, but eventually here you can look at all this stuff and it gives you all these nice examples of data that you can look at. But eventually what you're looking at is just a more specific version of this. So let's look at the data manipulations. You can pivot things. You can merge ordered. Apparently this is a link. Here's the specific documentation for merge ordered with all the parameters and the return type, which is a data frame. And it has a C also, so you can look at merge. This is how documentation is written out. And if you fully understand all the stuff that we talked about today and in the rest of these classes, then you won't be able to necessarily understand everything here, because a lot of this is specific to the library that you're using. I have no idea what like indicator means. In my usage of pandas, I've never had to do that. If I try to look at indicator, okay, it says it adds a column to the output data frame called merge with information on the source of each row. I could try to read all this and understand it, but eventually, right, like it all comes back to understanding the key concepts of how Python works. Okay. Um, so let me see. We have 10 minutes left here. I think now's a good time to answer some questions that have built up. So let's start with, I'll go in order here. Um, Someone's asking, can I share this notepad file? Um, sure. Do you mean, actually, uh, a thing I will do, um, I will take all of the files that I've made for all of these lessons, since it seems like people are interested in having these files in particular. I will take all the files that I've made in all these lessons. I will make a public repository of them using GitHub. And I will post a link to that repository um, into the forum so that everyone can have it. So I will share all of them. Okay. How can you find the API URL on a website while trying to scrape? That's a specific question to the website. There's not a general answer to that. If you're trying to scrape websites, they all have different ways of formatting their URLs, and that's part of the art of web scraping. In this case, like this website's very simple, so I literally just copied and pasted this, and that worked fine. But yeah, there's no general answer to that, and that's for a whole other lesson on web scraping. Okay, someone's asking what exactly is Pandas. Pandas is a library that's meant for going through a bunch of data and working with it kind of like a spreadsheet, but more programmatic than a spreadsheet. It does a lot of stuff. So, like if you look at like the Pandas documentation, it has all sorts of stuff here. Like if I go to just the API reference, the API reference is huge. It does all sorts of things. But ultimately, what it's for is working with a bunch of data and cleaning it up, doing operations on a bunch of data at once. But you'll run into it if you try to do a bunch of data analysis in Python. If you were understanding all the things I was doing with nested lists and dictionaries, Python will be no problem. What is an API? Right, that's a great question. So API, what is it? Application Programmer Interface. That's I think what it literally stands for. Although I might be misremembering that. An API is a general concept in programming. So the idea of an API is if you want to use someone else's code, then what you don't want to do is have to understand every single bit of how they made everything, right? You want to just be able to use the stuff that you want to use. In other words, all you want to know is what do I have to give it as inputs and what am I going to get back as outputs? It's the same thing I was talking about yesterday. So an API is specifically what a piece of software guarantees to you in terms of just the inputs and outputs. So let's go back to requests, which has a much simpler API. So if I just look at get, right, here's the entire thing for get. What the API is, what an API tells you is here's how to call the function. You do it like this. Here are the parameters of the function, and here are what the parameters mean. And here's what you get when it returns. An API is just all of that. It's what are the inputs and what are the outputs of this thing. You'll notice that they don't put here part of the actual source code of request.get, which you can look at. here it is. This isn't actually a very long piece of code, but if I wanted to look at the source code for request.request, I bet it's a lot longer. Yeah. There's a lot going on in these two little lines of code. This is the actual source code for how it works. Somewhere in here, I'm sure. Yeah, it imports sessions, which is a whole other thing. Um, so instead of having to look at the source code and try to figure out what all the source code means, an API is just telling you how is it used. Application programming interface. Yeah, that's what it is. It's not programmer interface, it's programming interface. Yeah. Okay. Any other questions? We have about 5 minutes left. So at this point, this is the last of these classes. So, we're not going to meet back up after this. But if you understood all the things that we were talking about here, let me give you an idea of the kinds of things that you should be able to do. So actually, let me go to my own GitHub. GitHub is a website, by the way, for storing programs that you've made and things like that. So here's something that I did when I was an undergrad. I did a little experiment where I took my sister and mother are auditory dyslexic, and that makes them unable to differentiate certain unable to determine certain vowel sounds from each other. And I did an experiment where I had them, where I figured out. Oh, so anyway, I did an experiment with them where I played them various vowel sounds and did analysis on the results of that. And to do that, so I made this script as the thing that actually played all the sounds and logged all of the data. So to actually run the experiment, here's my this was my code that did that. I used a library that plays sounds, right? So here it plays the vowel sounds. I made a function that prints out this. It tells the user to listen to the sounds, and then it plays them. Then it asks, were the vowel sounds the same or different? Type same if they were the same and different if they were different. And then, it keeps track of their answer, and it, logs all the data, right? It organizes all the different tests, and it made, this is a data frame, this is a pandas data frame of all the results, and lets me enter the name of the subject and collected all the data. After doing that, right, I made some code to figure out what the actual acoustic properties of the sounds I was playing were. And then let's just look at it like this. I did a whole exploration of the data. This is using something called a Jupyter Notebook, which lets you run just a little bit of code at a time and look at the outputs. And, here is some of the results I got. And, I was able to use Python, thing called matplotlib to make little plots for myself and get all these interesting results. And this I was able to turn into a whole little undergraduate paper, but a more sophisticated version of doing this exact same thing. If I'd made my experiment a little bit better and I had, more formally stated my hypothesis, these kinds of plots could have been absolutely valid research. Maybe done it with more people instead of just my sister and my mother. And all of the key stuff here, I did just by looking up, how various Python libraries worked, writing up this code, and writing the code to run the experiment and give things through to people. And all of this was something that I was able to do in, I would say, a few weeks of work total. Um, Now, I have a lot more programming experience than you, so there are things that I did here that might be a little bit fancier than and at the time I had, I already had a few years of programming experience, but this is the general idea of the kinds of things you can do if you master the skills we talked about in this class. You can do this kind of thing where you uh, gather a bunch of data in Python and then analyze it in the ways that we were talking about by storing it in different ways and going through and counting different stuff. All this plot, by the way, this is just taking numbers that I found in some simple way, and plotting the stuff is really easy. All I had to do was go through all the stuff that I had, set labels for my axes, and just like this little code right here makes all these fancy graphs. Um, Someone's asking to share this GitHub link. Some of the code here is a little bit messy, but sure. Absolutely. Let me got in my own way here. Just go here to the top level. Actually, let me make sure I get the link right. I know I have the link right here. Oh, nope. That's not going to work. Okay. I think it should work. You guys could tell me if this link works. So I think tree, whoops. Go back to Zoom. Problem with having too many windows. Okay, there we go. Tell me if this link does not work for you. But okay. There are a few more questions here. What is HTTP? HTTP is part of how accessing web pages works. It's in the start of a lot of URLs. That's its own whole long story. We definitely don't have time to talk about how the HTTP protocol works. Okay. Someone's asking, can we reach out to you for any challenges? There are hundreds of you and only one of me. So you can certainly try, although like if I get a lot of these messages, that might be a little much. My biggest recommendation, if you run into challenges, is to try to reach out to each other, because you all might be able to help each other much more efficiently than I can. Someone's asking, what resources can you use to learn more about Python, especially for linguistic analysis? At this point, you've pretty much learned all of the absolute core basics that you would need. From this point, the best way to learn more is think of tasks you actually want to accomplish, try to accomplish them, and when you run into something that you don't know how to do, then it's just a matter of, can you find the thing that lets you do it? So some of the big ones, like some of the big libraries out there that will help you do things that you're trying to do, are like requests for doing things with web scraping, and then like something like Beautiful Soup to actually process the HTML that you get out of that. Pandas for all sorts of data stuff. If you're doing linguistics things specifically, there are a bunch of libraries that are meant to interact with things like Prot for phonetic analysis. There are libraries that are meant to interact with LaTeX if you're trying to like programmatically do things for papers, build out like LaTeX trees out of data. That's something that there are libraries for. Okay, great, link worked. But the whole point of the Python ecosystem is all of this stuff. If you Google the specific question that you have, you are likely to run into people who have at least done something similar enough that you will be able to get on the right track. Someone's asking if I can explain web scraping. Yeah, that's certainly not 3 minutes after 11, 11 my time. The idea of web scraping is it's getting a bunch of data by reading it off of web pages. And yeah, that's a whole lesson in and of itself because you have to learn how HTML works and a bunch of other stuff. The reason I use the request library is just to show you what a library looks like when you look one up. Um, okay. Any other final questions?
So yeah, I think we don't have any other questions. Let's everybody celebrate Jacob for coming around and taking these classes. This is one of the simplest Python classes I've ever attended that does not only make you to program, but make you an efficient programmer because there's a difference between writing the code and understanding what the code is doing. So you might know the code, but barely would you see anyone that is able to walk you through how to think like an interpreter yourself. That is amazingly awesome. Yeah, let's thank Jacob for these interesting classes. So everything will be for the Python class. We are happy that we are able to put everything um on the YouTube. So that's a huge support from Jacob. So if you have any question and you have anybody struggling, you can just give them the videos to watch. Anybody that cannot sit down to watch the videos, they might not want to learn Python actually in the first place. So thank you so very much, Jacob. We so
I have
happy.
one final piece of advice. I realized I forgot to say one of the most important things.
Mhm.
Um, One of the really unintuitive things about programming is that code is actually easier to write than it is to read. That's something that if you don't have a lot of experience, like especially if you're used to language, right? Of course, it's easier to like if you're talking about papers, it's easier to read a paper than write your own, right? But with programming, um, the only way if you need to do something complicated, the only way you're going to be able to understand it is by trying to write it. And if you need to read someone else's code, the way that you read code, the real way to do it is to act like you're the one writing it. Take parts of it and try fiddling with it. Take parts out and try changing out the lines. Become the writer of the code, and that's how you will read it.
Excellent. And to add to that, it's actually the case that there are a lot of these um, documentary repositories. If you know how to look up like GitHub, the first time I would script a web, I didn't write like 98% of the code myself. I was just browsing around and I saw a README file somewhere and I just put it in my PyCharm and it ran well. And I just changed the link of the website and I got what I wanted and that was it. So I think learning how to read the library is extremely important because especially if you want to do NLP work and you want to do things around computational linguistics, in fact, I can tell you for a fact, 99% of these papers that do things like ASR system, like doing text manipulations, have their repository with the code that they use together with everything, like the README file, even the data they use. So if you know how to read the library and you can follow what Jacob just did, it work exactly the same way. And you can just do anything. So if you want to do like sentiment analysis, for example, and you don't know how to start, just browse. You can use Hugging Face and say, okay, sentiment analysis on this, follow their paper and follow their GitHub repository. You will see the code, you will see the Python code, you see everything there. You can just copy it one batch, one at a time, and see what it's doing, change the directory to your own data and be excellently on point. So that was one of the reasons I took the linguistics data for machine, where I wanted it to be that, okay, now I can see an NLP task, I can build a data set for it, and I can prepare the data set when I see a paper, I see the format of their data, I see how they structure their data. I can put my own data like that too. It will be different language and it will be different result because you are dealing with different languages, right? So I can just look at a sentiment analysis paper in English and just build a data set in Igbo or Swahili, whatever language, follow the format that that they used and do the same thing they did, and I will get different results, but the same architectural design. So coding, it's just like that. It's like architecture. If you are doing the same task, most of the time it's usually like the same step and the same process. You don't have to like keep repeating what another person have done. And I think Jacob has stressed this a lot, that if you check online, you can see different ways of doing what I just did now. So it's not like this is the only way, and there is no right way actually. So you can just keep playing around things. So yeah, thank you so very much. That is really that's really a great class. So yes, let's end the recording here.
Thank you all so